The tree pane shows the taxonomy of gadgets grouped by operations in class. The first level of the tree shows the classes. An histogram aligned to the list of classes suggests the number of available operations for each class. By clicking on a class, it is expanded and the list of its operations is shown. A second histogram is aligned to the list of operations. The width of the bars is proportional to the number of available gadgets. Once the desired operation is identified, the list of its gadgets is available by clicking on it. A gadget is identified by its assembly code. For each gadget, the memory requirements bar shows the space in the stack required by the gadget to work properly. The color encodes the stack occupation with respect to a memory threshold. A green color indicates that the size does not exceed the threshold, while a red color indicates that it does. The memory threshold value can be changed at any time. The dereferenced registers matrix shows, for each gadgets, the registers used to access to the memory. Each entry of the matrix is filled by a rectangle if the gadget dereferences the register. The color of the rectangle is associated to the register. The registers pane contains all the registers, identifiable by their name and color, and the checkbox that, when is checked, filter from the tree pane all the gadgets that modify the register. The filter bar allows to explicitly define the filter using a proper language. More information of a selected gadget are displayed in the analysis pane, that shows the semantic of the gadget, its assembly code, its memory address, the registers that it modifies and the ones that it dereferences. The similarity pane presents all the gadgets that execute the same operation as the selected one, showing the dissimilarity matrix. By clicking on the box, the gadget is added to the chain. The current state of the built chain is visible in the chain pane. It is represented as a sequence of rectangles in which each rectangle represents a gadget. The background color of the rectangle corresponds to the color of the register set by the gadget. Inside a rectangle, registers used by the gadget are shown distinguishing between dereference registers, on the left of the rectangle, and source registers, on the right, using the same convention seen in the tree pane. We start by filtering out gadgets that perform memory accesses by using the Avoid Memory checkbox. We look into gadgets from the loadcons category to determine which registers can be initialized with an immediate read from the stack using a single gadget. Then we select the first gadget in the list and set its value. We add to the chain other two gadgets. We use the filter pane by typing the name of the register. The system will present us with two alternatives, both dereference and register racks to write to memory. We chose the first one due to its smaller memory requirements, adding it to the chain. The system highlights a dependency for the newly added gadget, therefore we write a special identifier in the first gadget. We write another writable address in the last gadget. We select the first gadget and duplicate it, adding it at the end of the chain. Using the filter pane, we select a gadget implementing the required loadconst. Then the gadget is dragged in a new position so that a valid address will be used for the memory access. We filter gadgets and then we select the first proposed one. Like the previous actions, we added a duplicate instance of the gadget. We search for a gadget containing a size call instruction and we add it to the chain. The chain is now completed and can be exported to a Python script using the dump functionality.